I don't want this presentation to be about causaLens and what we do. I want to tell you more about what we believe is going to be the future of data science and how you guys can fit into that future. So I want to share today the vision, my vision and my team's vision of where data science is going. And so I will share now a few slides to outline that vision, because I think it's really important. It will be a big mistake if we do not start going on this path earlier. If we spend more, a few more years on the current path, I do not think we'll be able to unlock the potential that data science can bring to the world. So today I want to tell you a little bit more. We'll forget causaLens. We'll talk about what we believe is the direction in which data science is traveling, and I'll explain why that is. So I'll share my screen again. Just give me a second. So machine learning has had some amazing achievements over the years, right? If I have a lot of pictures of a cat and I have a very powerful computer, I'll get something like 99.999% accuracy, right? And it'll be fantastic at recognizing cats. We've had some incredible achievements in autonomous vehicles. We've had the world champion at Go has fallen at the mercy of DeepMind's machine, and that's been fantastic. And it's very tempting to look at these examples and extrapolate and say, yes, now we've achieved artificial general intelligence. We can do anything now. We don't need humans anymore anywhere. We just deploy the machines. Unfortunately, those two examples are examples of what I call static systems. Systems that are always constant, meaning a cat always looks like a cat, right? Unless an alien cat falls from Mars or somewhere else, a cat will always look like a cat. The game of Go is a board game, right? The board is fixed, the pieces are black and white, and there are certain legal moves that one can make. And therefore, it's a static environment. And machine learning has done incredible things in those static environments. But imagine now a machine learning system for the first time seeing a cat dog image, something that looks like this. It would just have no idea what it was. It will say it's either a cat, it will say it's a dog, or it will say I have no idea. Or it will say, oh, I have a cat and a dog in the picture, right? But if it has never seen a cat dog, it will just not know what that is. But us as humans, even if you've never ever seen such a picture, you can just infer from understanding of the world that this is a cat dog, and therefore it does not exist, and it's just someone has put two pictures together, right? But current machine learning techniques are really just unable to recognize what that is. And actually, some of the most exciting use cases for data science are in our dynamic world, in the world of business, where things are continuously changing. It's like a world full of cat dogs, things that we have never seen before. A pandemic arrives and the past no longer matters. So learning from it is irrelevant. So being able to do this is actually not possible with the current techniques, because they can simply cannot learn from very few data points. They require a lot of data, a lot of stability, fixed rules, and then they do very well. But when the world is changing and there's lots of cat dogs around, they fail. And the reason they fail more technically is because they're fitting curve through the data. They're taking some data points and say, okay, what is the most accurate function I can fit through this data? So if I have this data here on the XY axis, I can fit these three different curves, right? The curve on the right is probably a bit of an overfit. The curve on the left is a bit of an underfit, but that's all I've done, right? If I have some really complex deep neural network architecture, all I'm doing is I'm still doing curve fitting. I'm just doing it in a multidimensional space, and I'm fitting a hyperplane. But the reality is I'm still fitting a curve, and fitting a curve does not tell me anything about the world. So as soon as the world changes, my fit just is stuck in the past. It's like driving forward by looking at the rear view mirror. And I guess this is just a bit of a cool example I like to show, just to say that we have a problem currently in machine learning. An artificial neural network, if we're doing something cool, would burn the same amount of CO2 as a vehicle over its lifetime. So the computational efficiency of a neural network just to learn something is terrible, right? It's like one car for 10 years emitting CO2. That's how much CO2 we need to train one, to solve one small problem. Now imagine if we're trying to solve many problems, right? How much CO2 we would emit. But actually, that's not my point. This is not a message about saving the planet, but the message is actually that the brain, which is actual, it's a natural intelligence, can do many things, only requires 20 watts to work, right? And that's the same as a light bulb. So when we compare current approaches and our brain, something does not add up. Why do current approaches take so much energy and are that susceptible to just a small change in the world, right? So something does not add up. So we think that the current approach to doing data science, to doing machine learning, is fundamentally broken. And that's the video I showed you earlier, where the cat thing, if we had a computer vision system to look at this, it will infer that the cause of the fall is the cat. So in summary, we need a new science because something is not right. Our algorithms do not work in dynamic systems. They take a lot of CO2 and energy to train, and we're unable to do it at scale. So we need a new science that we can, for the first time, teach machines to understand the world very much like we can. And that requires few things, right? We need machines to start imagining. We cannot simply rely on past data because past data will just be a perfect way to learn the past. It will be just like driving forward by looking at a rear view mirror. So currently machines cannot imagine things, but us as humans, we can, right? For the first time we see the cat dog image, we can imagine, all right, it is just a cat and a dog put together in an artificial way. Artificial imagination is something that current approaches cannot do, but it's super important. If you imagine just doing like a simple what if exercise that you do on a daily basis without even thinking about it, you think, okay, if I do not throw the trash tomorrow when I wake up, I won't be able to have my breakfast. Or I don't know, if I don't go to the shop, I will not have anything to eat. You don't need to do that 1,000 times, not go to the shop and be hungry to actually realize that you'll be hungry if you don't go to the shop. So you don't, as a human brain, you don't need training data to learn things. And we want, I think, as a community to start building algorithms that can do these sort of things. And that's really exciting. If we can give machines imagination, then they'll do really imaginative things. And we can start solving problems that we were never able to solve. Another thing we want machines to do is they want to learn from us as well. We want to have some sort of interface between us and the machines. Currently, there's a very, very, very limited way to interact with machines, right? Okay, you can decide what features go into an algorithm and things like that, but that's not how intelligence necessarily work, right? You never think, when you think about some complex problem, you're not like, oh, I'm just gonna look at this 3 things and I'm going to ignore everything else, and I'm going to make a decision of some sort of linear combination of them, right? Decision making is a lot more complicated process. So therefore, current approaches there's no cool interface between our human brains and the algorithms that we're currently using. So we think if we're going to unlock a lot of economic value and change the world, we need to find a better interface between machines and us, because we are cool, we have really cool ideas and thoughts, and we can come up with a hypothesis and we can bring some cool ideas, and currently we just cannot give that to the machine, right? We're just limited. Okay, we're going to choose the features, great, right? It's very, very limited. So we need to find a much better way to get humans and machines to work together, and then we can do even cooler things. Now, needless to say, this is super hard, right? So the reason I'm telling you guys today about these problems of car machine learning is that I'm sure you're all super smart and you're at that time, point in your career when you can make a real impact. So I just want to invite you to join our mission and bring this new science to life. It's going to be very hard, but it's going to be super fun as well, right? We're gonna, if as a community we come to realize that the current approaches are not going to get us there, because the current approaches have no imagination and they do not allow us to interface with the machines. If we realize that, we will start working together and we will invent a new way to do this. And then we can solve many things that we currently cannot solve. Now, it's not simply enough to come up with a new science. We also need to automate that science, because solving real world problems requires many models, right? So we need new science to help us understand cause and effect, help us bring our human domain knowledge into the machine, let the machines dream. And we also need to automate so we can do this at scale, right? So those are the two things that we need to work on: new science and automation. And I would invite you all guys to join on this mission, because this mission of causality and causal AI is not just our company's mission. This should be the mission of the community as a whole. And we want to, no matter whether you're with us or with someone else, we'll be super happy to help to advance this cause, because it's super hard. Now, I just wanted to share that although it's really hard, it can do some amazing things. And we are, of course, at the forefront of this, and we are already doing experiments, and we have solved many of these problems. I just wanted to show you that this is not just some hypothetical thing that I'm saying. This actually can bring some real tangible results that have made real change in businesses. So these are models on the right in red, are models that have been built with causal AI. Models on the left in blue are models built with conventional state-of-the-art machine learning techniques. And you can see the difference, right? Imagine if this was your health on the line, and an algorithm told you with 55% confidence versus 95% confidence. Or imagine if this was your pension on the line and an algorithm was only 52% right versus 90% right. Imagine if this was your flight schedule, or your, anything, right? Your traffic light system. Anywhere you look, if we can move from where we are now, the blue distribution of model accuracy, to the models on the right, all of our lives will just become so much more exciting, much better. We will, as consumers, will pay less for services. Companies will be able to serve us better. We will have a less impact on the environment. We'll do many things, right? And so maybe I can paint one picture of where we've kind of had really cool result. We'll come to this in a second. I want to just share one use case where we're able to save a large number of CO2 tons of emissions and a huge impact on the bottom line of one of our customers by applying causal AI into the environment. So imagine you have the job of optimizing a logistics business. Let's imagine, for the sake of argument, it's DHL. What is the job of DHL? Well, it is to fly planes around the world and deliver things, right? So you order something on Amazon or whatever the case is, and for that to come to your house, a plane has to fly, right? And it just happens that there are about 10 million permutations of airport pairs in the world, right? And of course, planes need to fly tomorrow, the day after tomorrow, the day after tomorrow. So then the number of permutations of things that you need to consider just grows even more, right? So now imagine you are given this as a problem, and your job is to predict how many packages are going to be flown between all of these airport pairs for each of the time periods. To make it even more difficult, you're told that planes have a capacity. You cannot put more than X number of kilograms in a plane, and you cannot fly more than X number of planes a day between destinations, and you have to book and reserve planes ahead of time, 3 months, 6 months ahead, right? Now you have to do all of these things, and you have no idea what the demand is going to be tomorrow, in 2 months, in 3 months. In other words, what I'm trying to say is you need about 10,000 to 10 million to 50 million models, individual models, to be able to even start understanding how many things you're going to be flying around the world. And now imagine having that as a problem. You have a team or you're just alone and someone says, okay, go and build me 50 million models. And by the way, these models have to also adapt. So when the world changes and we have a pandemic, you have to rebuild the 50 million models. It would sound like an impossible challenge to you, right? It would sound like it's not possible to do. And it will also sound like, well, how will I know if I have the right things to go into the model? How do I know what are the causal drivers of this package going from A to B? So if you use the current approaches, you will spend probably 3 to 6 months just building one single model. And when the pandemic arrives, or I don't know, Chinese New Year happens, or Christmas happens, your models are just going to be out of whack, right? Because you couldn't figure out the causal drivers of that model, and you were able to only build one model, right? Not the 50 million. Now imagine if you had a magical technology that was able to automatically do that, but not just to automate our current processes, but to also understand what are those causal drivers for all of those 50 million models. Then you could know exactly how many planes you need in 3 months or 6 months time. You can book the right number of planes. You can make sure their capacity is as full as possible. And you will actually end up flying half of the number of planes that you flew before, and therefore will result in large number of tons of CO2 emission being saved. And if you're DHL or FedEx or whoever you are, will save a huge number on your bottom line, right? You'll fly half of the planes you had to fly. So in summary, at causaLens, we have developed technologies to do just that. We can say we want DHL or FedEx or whoever it is to be optimized, and we execute this one line of code, FedEx or DHL.predict.optimise, and magically we save a lot of CO2, and we have DHL or FedEx get their bottom line in order. So everybody wins. You win because your iPhone arrives on time. The environment wins because we just flew less planes around. The company wins because they made more profit, right? And so just wanted to illustrate that one example to show the power of what we are trying to do in this world, right? We as data scientists, developing the right technologies and spending our time in the right places, that's the most important bit, we can make a real change in the world. We can touch every aspect of our life. So in summary, I invite you all to think about causal AI and where do you spend your time. Do not spend your time optimizing hyperparameters in sklearn, please, because you're not going to help the world. You can only help the world if you realize the shortfalls of current approaches and you join the mission to develop causal AI. And then we can do fantastic things. And if as I said, causal AI is not our thing, right? That's something we want the whole community to be part of. But if it happens that you wanted to join us on that mission, you're very welcome. We have a lot of opportunities. But if you wanted to do that with someone else or yourself, that's great as well. So here I'll just outline some of the cool things that we do at causaLens. We're a data science company that is driven by scientists and engineers, right? Even our marketing teams have data scientists, and our sales teams have data scientists. And here I just want to outline the types of data scientists that we have, because I think so far everyone seems to be bucketing the world into kind of, there's only one data scientist, right? But we believe there's various numbers. And here we have actually 4 different types. We have data scientists, which are in marketing. We have data scientists that work with customers on helping them achieve this. We have data scientists working in our product team that are helping build the product. We have data scientists that are bringing forward the state of art in causal AI, right? So when you think about your career, also think about it, where do you want to be on this journey, right? Data scientists are not all the same. There's different angles to it. Everyone is equally important, but you need to understand what do you get excited about and where are your skills mostly suited for.